There are other types of quadrilaterals that we can talk about. One, a trapezoid is a quadrilateral that has exactly one pair of opposite sides that are parallel. A trapezoid has two adjacent right angles is called a right trapezoid. So the example shows two right angles on the left side there. And then the other side is not other side has different angles. A trapezoid whose non-parallel sides are congruent, so are the same length, is called an isosceles trapezoid. And then a rhombus is a parallelogram that has four congruent sides. So just kind of note that a square is a type of rhombus. A rhombus is not necessarily a square. A rhombus could be like a squished square. And we'll talk about one more, but first I need to define some terms. A closed figure in a plane is convex when every line segment connecting any 2 points lies entirely inside the figure. And it's called concave when at least one line segment connecting any 2 points lies outside. So essentially what this means is kind of imagine that this is these shapes are rooms and you and your friend are inside the room. If you and your friend are always within each other's line of eyesight, no matter where you go, that's going to be a convex figure. So for the example on the far left, no matter where I am or no matter where my friend is, we are always within each other's line of eyesight. A concave figure is one where my friend and I could could position ourselves in a place where we can't see each other. So for example, for the first one, the first concave one, if we were both in those corners, there's no way that we're in each other's line of eyesight. There's a wall blocking us. So you can think about, so if you're having trouble understanding this definition, just think about that. If imagine that these are room designs and you and your friend, no matter where you go, you're within each other's line of eyesight. That's convex. If you can hide from each other, then that's concave. So in terms of which figures are convex or concave, part A is, well, essentially A is convex. No matter where I put myself or my friend, I can always see each other. Same thing with part B. Oops. Part B is also convex. Part C, if I put myself in that right corner and my friend out of the other corner, you can see that we would be blocked. That there's a wall that would keep us from seeing each other. So part C is concave, as is part D is also concave. So concave is just that there is a place somewhere in there where you and your friend can be outside of each other's line of eyesight. All right. So anyway, a kite is a convex quadrilateral. So it's one where you and your friend are always with each other's line of eyesight. It has exactly two pairs of adjacent sides that are congruent. So if opposite sides are congruent, that would be a rectangle or a parallelogram. If adjacent sides are congruent, we have a kite. So like the two sides on the left are congruent, the two sides on the right are congruent. That would be a kite. So part of the definition is that a kite is a convex figure. So I'll try to draw a quadrilateral that is not a kite, but it has exactly two pairs of adjacent sides that are congruent. That would look sort of like, it would have this kind of look to it. Where, like, say, these two sides in the inside are congruent, and the two edges on the outside are congruent. Or there's a better shape. That's a kite. And here's an example that's not a kite. All right, so in the kite shown, the upper left and right triangles are isosceles right triangles. So that tells us that we have right angles in the middle there. The lower left and right triangles are also right triangles, in which the least angle measure of each is 30 degrees. That looks to be at the bottom there, so that would be 30 degrees. This would be 30 degrees. Okay. And if you have one angle that's 60 and one angle is 30, then the angles of a triangle add up to 180, so the missing angle would have to be 60. So we can see that these two there in the bottom have to be 60. All right, and what we also know is the upper left and upper right are isosceles right triangles. That means, so let me draw that left triangle there. We know it's right triangle. This isosceles right triangle means that the two sides next to the right angle are congruent, which means that the two angles are congruent as well. So whatever they are, let me use a different letter. Let's say n. What I know is that n plus 90 have to add up to 180. So 2n is equal to 90. So n has to be 45 degrees. And that gives us the rest of those. So in terms of the angle measures of the kite, figure out what x, y, and z are. Looks like x is made up of two 45-degree angles. So x has got to be at a right angle. Y is made up of a 45-degree angle and a 60-degree angle. So y would be 105 degrees. And z is made up of two 30-degree angles. So that would be a 60-degree angle. And there's two angles that are both y, so that would account for the four angles. Okay, couple more questions. Classify each quadrilateral in as many ways as possible. Well, first off, if they all have four sides, they are a quadrilateral. So we can start with that. Part A, the opposite sides are parallel, so this would be a parallelogram. I can't say that the sides are congruent, so I can't talk about rectangle or rhombus or anything like that, so I think that's as far as we can go. It's a quadrilateral and it's a parallelogram. Part B, it's not parallelogram, but the opposite side or adjacent sides are congruent, so this would be a kite. Part C is we have a trapezoid. We have one pair of parallel sides, but I don't know if it's a right. I don't know if it's a right trapezoid or isosceles. So the best we can say is a trapezoid. Part D is also a trapezoid, but you can see that the left side and right side are congruent. So this is going to be an isosceles trapezoid. Okay. And finally, let's talk about the always, sometimes, or never true for each of these. A rectangle is a rhombus. Well, not necessarily. A rectangle has four right angles. A rhombus does not necessarily, but it can. A rectangle that is a rhombus is called a square. Squares are rectangles and they're rhombuses. A square is a right trapezoid, and that is never. And that's because a square has two pairs of parallel sides. A trapezoid only has one. A trapezoid is convex, and that is always going to be true. There's no way to have a one pair of parallel sides. Then it's not convex. So that one is always true. The parallel sides of an isosceles trapezoid are congruent. Well, an isosceles trapezoid is sort of like this, where the left side and the right sides are congruent. But for a trapezoid, it's going to be impossible for the other pair of sides to be congruent. So this would be a never.